Okay guys, today we're gonna talk about tests and actually infrastructure around them. So a bit about my experience and background. So I'm R&D team lead. I'm not a QA. I'm not automation QA. I'm mostly developer that needs to ensure quality of projects and products that I'm doing. So why do we need tests? Basically, we want to have less bugs in production, right? So in order to figure out how we want to achieve this, let's take a look at our sample architectures that we have usually in most of our applications. So we have front end, we have back end, some web server and a database connected to it, and front end usually does HTTP requests to our backend. So today I'm going to talk about mostly integration tests, tests to a backend. And in order to make sure that we don't have bugs or have less bugs in production, right? We need to replicate the action of our clients. So actually, tests will be our client that will do HTTP requests to our backend. As a simplest example, we can take a look at applications that consists of Node.js applications that connects to MongoDB. Let's talk a bit about our requirements for our tests, right? So they should be easy to write, they should be easy to stop locally, they should be easy to stop in CI/CD systems, and they should be as close to production environment as possible. So for this presentation, I wrote a simple Node.js application, just a regular application that connects to MongoDB, does post requests to some endpoint, and so it writes some entity to MongoDB. So obviously it's not a production grade code. It's just to demonstrate you some infrastructure of tests I'm going to show you later. And we have another endpoint that we can retrieve our paths by some ID. So in my opinion, this is how should look the simplest test to our application, right? So this before section shows the initial setup. So we should connect to our database just to have some extra flexibility in setting up our tests. So we should prepare our database, or we should clean it. So we should clean the state before actually doing some actions. And we should start our application also. So I'm doing everything in scope of tests. And actual test, it will write some data to our HTTP service, and we'll try to retrieve it, and we can compare if received object is the same as we've sent. So you can see I'm just sending object with name patron with some ID. If you're wondering what this patron means, so actually patron is a dog that helps Ukrainian forces to demine Ukraine territory. Okay, so what are the options to run third parties? So in previous example, I showed that we connect somehow to MongoDB, right? But I didn't show how we actually spin up this MongoDB. So what are the options here? So first obvious option is to mock it, right? So if you write some implementation of MongoDB in JavaScript, it should be easy to run in all environments, but it will not represent production, right? So we'll test only our code, only our mocks. It's not close to production. We can change, we can implement our mocks wrongly, meaning that, well, in production we'll have problems again. It's not what we want to do. And also, whenever we'll need to update MongoDB, for instance, then we'll need to update our mocks. It's pretty hard actually. So what else we can do? We can run our MongoDB on our computer. We can download the binary or package file or DMG file and run the installation on our macOS, right? So it's pretty familiar way how to install third parties. It's a real database, so it has more chances to represent production environment. But the problem here, it's gonna hard to set up MongoDB in all the environments, right? So remember, we need to set up MongoDB like locally on our machine on CI/CD. And basically, if we look at how many different systems we need to spin up, it's the number of different instructions is going to be infinite, because we have different processor architectures, we have different OSs, and number of Linux distributions is infinite. So it's pretty annoying to set up a database on your host system, on your machine. Okay, another option is to write everything in Docker ecosystem. So pros are obvious. So if you set up everything in Docker ecosystem, it should be easy to run in all environments. It should be pretty close to production, because we're gonna use like images from vendors, right? The downsides here are that initial setup may take some time, and debugging container is harder. It's well, everything is like in virtual environment. It's actually pretty hard to access. Another option is to use dedicated cloud infrastructure for tests. So good parts of it. So it's as close to production as possible, but the more developers you have in your team that's gonna access this infrastructure or run the test, it's gonna be harder to isolate different test runs from another. It also can cost money to run infrastructure in clouds. It might require VPN access or internet access, so you can develop in trains, in planes, or with poor internet. Sometimes it makes difference. But in general, despite all the cons, I'm recommending the third option, to run everything in Docker ecosystem. And let's try to figure out if it's hard to spin up everything in Docker infrastructure. Okay, so in order to run tests in Docker infrastructure, we need to build image for application with tests, right? So we need to spin all the services, third parties. Then we need to run all the tests in containers. Then we need if we need to change the code or the tests, what? We need to repeat all the steps from 1 to 4? It doesn't sound convenient at all. But what if I'll tell you that we can solve all our problems with just one command? And this command is docker compose run. With docker compose run, let's take a look deeper to that. I explain why it solves all the problem. So, but in order to make it work, I'll show you the sample docker compose YAML file with our infrastructures. So from this command, you can see that it actually running specific service from a list of services listed in Docker Compose, and it says nothing about MongoDB at all. So what we are saying in this command here is, okay, we just need this application to start. Then Docker Compose will check the existing service, and then it will check dependencies here that you can specify in Docker Compose. Then it will go to this service, figure out how to run it. Okay, here we need just an image download from Docker Hub. Here we have a health check to make sure that MongoDB started. Actually, it finished starting before we run our test. And afterwards, Docker Compose will try to run this service. Okay, we don't have image property, we have a build property, meaning so Docker Compose will understand we need to build Docker image first if it doesn't exist in this application. So we can specify custom entry point different from what we've put in a Docker file, meaning that our production Docker file can stay the same as our Docker file for tests. So we can actually keep one Docker file for all our needs. And this section will help us not to rebuild a container. So I'm talking about volume section. So this section will not, will allow us not to rebuild container or image every time we run our tests. So basically, we are mounting all our files from local system to the Docker system. So whenever we change files locally, they will change automatically in container. It's very useful. So in order to demonstrate how it works, I've pushed this project into two different, let's say, most popular Git services, GitHub and GitLab. So both of them, they have our own built-in CI/CD system. So let's go and check them. Yeah, by the way, they are public, so you can actually clone it, play with it, go to CI/CD systems like Actions, or GitLab runner and check all the stuff by yourself. Everything is public. So how to set up everything of that on GitLab? How hard it is? So the first part here, it's basically initial Docker setup. So we specify the initial image, we specify the servers we want to run. Additionally, we need to install Docker Compose plugin because by default it's not bundled in this Docker image. Some variables needed for Docker, and basically command is the same. Docker compose run, it's actually the same command as we use it locally. It's nothing here about MongoDB. It's just saying, okay, we just need to run our tests, and Docker compose can figure out everything by itself. So this is the output from this test run. So as I said, first it pulls MongoDB, then it starts containers in correct order, then it builds image if it's needed, because by default in fresh GitLab runner, you don't have this image as pre-built. So yeah, it will build it every time, but for test run it's okay. Yeah, and afterwards it will run the tests, Mocha, and what's important to see here that, okay, in this case, our CI/CD knows that job succeeded. But how does it know that our test succeeded or not, right? So something happened inside of container. So what happened? Actually, Mocha finishes with some exit code. So Mocha is a process, right? It finishes with some code. And actually, this exit code is a key to tell CI/CD system if test passed or not. And a good thing about this Docker Compose run that exit code from Mocha got propagated back to the main command and back to the host system. So this is how CI/CD knows the test pass. If test will fail, Mocha will exit with some different exit code, like 1 or 137. It doesn't matter actually. It matters it's not 0. And yeah, CI/CD will fail the build, and you'll see that tests actually failed. How is different to set up tests on GitHub? Basically, on GitHub, it's even easier than in GitLab. So by default, GitHub build runner, it already has Docker and Docker Compose plugin pre-installed. So, okay, as an extra step, you need to check out your repo. It's not by default. Okay, not an issue. So here we just go into specific folder, right? Because I have like multiple examples in my repo. Yeah, and that's it, the same. You have the same commands to run a specific service. And again, GitHub knows nothing about MongoDB that you need to run, and all the infrastructure is bundled in Docker Compose, and you can run it everywhere. So setup is pretty simple, and it's similar across different environments or even different CI/CDs. So trust me, it will work in all your local environments as well. Okay, let's take a look about a bit more complex infrastructure that we have. Okay, what we have, not a database that we are communicating, but some queue. I've took Kafka as the most popular queue system in our backend. What's wrong with Kafka tests? So in Kafka tests, you don't have IDs. You don't put some items by ID. You can't access this by key. So it's pretty hard to actually manage the state. You can only push to the topic. You can read from the topic. Okay, you can tell. Maybe you can recreate the Kafka topic every time we run our system. Maybe it will work in let's say on CI/CD, because by default CI/CD it does not have any topics. I mean, by during fresh run, you'll not have a topic in your Kafka, and there's not going to be a problem to, let's say, create new topic, because so you'll set be clean by default, but it's only for one test. What if you have multiple tests that accessing the same topic? So you might say, okay, so last time we've recreated entire MongoDB collection, maybe we can recreate the topic. The problem that recreating topic in Kafka takes a lot of time. So it's going to be not convenient to recreate Kafka topic every time for all your tests. And So it's pretty complicated how we can complicated situation, and let's take a look how we can deal with that. So again, I wrote another sample application. In this case, instead of writing to database, we just push some data into topic. Again, this code is available on both on GitHub and GitLab. And so let's take a look at our test. So this is a setup area where we connect to Kafka explicitly from test, so we can manipulate it for our needs. We start our service, or actually making sure that it started. So the trick here, how to test the things in Kafka, is to remember the offset that we've started the test. So remember, we always write to Kafka topic, and we can't access it by ID. So what we can expect here in our test, that in specific point of topic, special object appeared. So this we are getting. I'll show you later this helpers code, but here we should understand the main principles or a generic flow. So first we get offset from our topic, then we do actual test. So we do HTTP request to our service, and we can try to retrieve the last Kafka message based on specific offset. So okay, we can say we remember that we finished that last offset to Kafka was like 4 or 5, and we need to read 6 objects in this queue. And after we retrieve this message, we can actually compare it with our referent values. So this is our helpers to our Kafka tests. Get last Kafka message will actually subscribe to the topic, and then we'll go to specific offset in our topic. And what we need to do, we need to wait until the first message will be consumed, and then we can resolve our outer promise here. This is how we can get specific message. Yeah, and in short topic we need for initial setup of our Kafka, and by admin functions we can get specific offset for our topic. Here you can see 0. 0 means that we are assuming that we have only one partition. So as far as I know, Kafka is a distributed system. So in production systems you can have multiple offsets for different partitions. But for local development, by default, it creates only one partition, and we can operate just with that. Okay, how about infrastructure of Kafka by itself? So Kafka is a bit more complicated in terms of infrastructure too, because it needs another service called Zookeeper. So first you need to start service called Zookeeper, then you need to start Kafka, then you need to build Node.js image, and then you should run tests. Yeah, sounds complicated. But again, Docker Compose to the rescue. So as again, everything starts with this application, Node.js app test. It has some dependencies, Kafka, right? Okay, we just put it in dependencies, and we don't put anything about Zookeeper. And Kafka knows that we need Zookeeper, so it has its own dependencies. And it has its own health checks. So yeah, we'll start to run tests after we pass the health check on a Kafka. Okay, so why don't we have a health check on a Zookeeper? Shouldn't we wait until Zookeeper will start? Basically, yes, we should. But the point here, Zookeeper starts so fast, or actually Kafka can wait by itself when Zookeeper will start. So if it works without explicit health check, we can live without explicit health check. If it works, don't touch. But yeah, in theory, you can add some additional health check here. How it will look in a CI/CD system, surprisingly, it doesn't change at all. We just go to a specific folder, like I mean, here I go to specific folder because I have multiple projects in my repo. How it will affect our CI/CD service like GitHub and GitLab? It doesn't change at all. We run the same service, and service takes care about its dependencies. And so this is how we'll look our log output. Yeah, Zookeeper starts first, then starts Kafka. So Docker Compose figure out the order of services it needs to start by itself. We don't have pre-built Docker image for our test. It will build it by itself, and it will run tests afterwards as it was before. All right, let's take a look to a bit more complex example. What if we have like AWS services in our backend? AWS Lambda, DynamoDB, Kinesis, and even more services like S3 or something else. For AWS services, there is another trick. So there is a service called local stack that is actually a set of mocks for AWS services. Basically, it does what it says. It mocks services. The good thing about it is that you can run it as a Docker image and put it into Docker Compose and use it as we had it in previous services. I don't have like real world example with it because basically it's the same. It doesn't change at all. But yeah, I said before that mocks are not good for a lot of scenarios. But for AWS services, I think this local stack is good to use because it's community driven. So it keeps up to date with community, and also in AWS, you have an option to fix API version that you're using. So most likely you'll not hit some breaking changes at all. So I'm highly recommended to check it out. I'm not gonna drill down to it, but just for you to know, it has you can use like up to 49 different services from this project. Yeah, so this Docker Compose YAML file example I've took from the official repo. But so I'm not recommending just to put image without any version, right? Because well, accidental unplanned update of image can lead to unpredictable results actually. So I recommend to fix everything. Like we fix versions of packages in package.json. Again, you should fix versions of image that you're using in your Docker Compose file. All right. What if we don't have mocks for that services? What if we have Google services that doesn't have any mocks? They don't have any official images, like data store, cloud functions, BigQuery, maybe cloud service. Okay, let's take a look, for example, with data store. So in this example, I skipped authentication part because for data store, let's say it's pretty hard to use data store locally. So Google has some official way how to run some mocks here, but actually I tried it 1 year ago and I didn't succeed. I gave up and I just started using some service in production. So I skipped authentication here because I'm connecting to cloud resources with my credentials. So it doesn't actually, it's not very different from what we have in MongoDB because well, what I'm doing here, I'm trying to clean entire data set. I'm deleting kind, so kind is kind of table in a data store, and just I'm trying to seed it with some predefined data. What is the bottleneck here in this setup? The bottleneck here is if we delete an entire kind in specific data store, then it can affect some other test runs that will run other developers or maybe concurrent jobs on your CI. So this will work for small teams, like deleting entire kind. But if you have more developers that need to run tests in parallel, probably you need to figure out a bit more tricky way how to clean the state for specific developers. Maybe you can introduce I don't know, some IDs that will start with the name of developer or a specific hostname machine or branch name or something else. But for small teams, this can work. What about Cloud Function? So actually, there are some kind of emulators for Cloud Function. So this is, I'm showing you this sample Cloud Function that I have in my production. So actual business logic I'm hiding inside of controller, and this is transport layer. I don't need to care about. I just leave it in my initial file as a transport layer. So the second option will be to write unit tests for controller instead of trying to call the HTTP server of this Cloud Function. So yeah, Google Cloud has its own, let's say, testing framework. But okay, what we can see in this test that Cloud Function exited with correct status code. So actually, it responded with correct status code to 100. But just for me, it doesn't test a lot. I mean, it doesn't bring any value comparing to tests that check some business logic. So anyway, so I trust that I trust Google in terms that they spin up this Cloud Function correctly. There is nothing that can change in this Cloud Function, let's say, HTTP server that they're using, right? Or this analog to HTTP server. So when I'm writing my Cloud Functions, for me, it's enough just to use unit tests to cover the actual controller of this Cloud Function, and it works for me. You don't need to, as for me, you don't need to use Google Cloud Function and do HTTP requests as Google suggests here. Okay, now our examples are getting even more complex. We have 10 different services. They have pretty hard workflow. No, we can have even more complex structure, like with BigQuery, with everything. There is no chance that you'll run everything like locally, right? So you have a lot of gears here in your big gear box, and the big question here: how are we gonna test this infrastructure as an entire gear box? Okay, let's just I'll answer this question later, but I want to show that we can have even more complex infrastructure. We can have something that can be maintained by several teams. You can have different applications, Lambdas, load balancers, I know, Redis clusters. What else? DynamoDB here, Athena, Presto, Elasticsearch, EMR, Flink, Druid. Infrastructure can go crazy when you're building a large product. Remember when I talked about this reinforce option, what we can use, like run everything in Docker ecosystem or use cloud infrastructure. So when it's impossible to run everything in Docker ecosystem, then it's time to use your cloud infrastructure for test. So yeah, I'm talking about QA environment. So a lot of you know about, I think a lot of you know that QA environment is good to use before pushing code to production, but normally people are testing everything in QA manually. But remember, I'm a developer, I'm a lazy person, I don't want to test everything manually. And also there can be a lot of changes in different parts of your systems, or some team deploy to a QA environment or something else, and you'll be not aware that something changed in the system. Your gearbox can become bigger and bigger and bigger. There is no chance that you'll monitor here. But wait, what we can see here, we can see Grafana here. Can we use Grafana for tests? What? To answer that, I can let's try to answer another question. How do you know that our application works good in production? So imagine that set of gearboxes or gears in a big gearbox, and actually we can have in more complex infrastructure set of gearboxes. How do you know that everything works in production right now? So first of all, I don't have any calls on my phone. My boss is not ringing me, and I don't have calls from support. So that's a good part. So I can give a talk to you right now. But the most important thing, it's metrics and alerts. It's something on what we are relying in our production. So we can actually have alerts on different things. Status codes, number of error logs, we can have some business metrics, we can have alerts on container restarts, resources usage, and so on. And basically we can use exactly the same in our QA environment. So we can just replicate everything in our from production to our QA environment, put a lot of metrics on it, and we can actually alerts can monitor everything for us, so we don't need to monitor everything by ourselves. Maybe it sounds obvious for somebody of you, but I'm pretty sure that you're not monitoring your QA environment as heavy as we are doing. But the regular problem of QA environments, right? What you usually do in QA, you open your browser, go to QA website, and try to click everything and see if it works. If you actually finished in the final destination that you are testing. So the trick here, how not to do it manually, is actually okay. We can automate everything that client does. So I've created a separate service called Client Automation that sends requests to the service like every second. So how it can look like in real world scenario. So we can send 10 valid posts to our /pets endpoint. We can send invalid requests, and we can try to retrieve these requests. And there could be a lot of things inside of our infrastructure. So some of them, some of them we are maintaining, some of them not. But basically, when we know exactly how much data we've sent to our entire infrastructure, we can predict how much data will appear in our final infrastructure. So we don't have one database in our infra. So we have one database to where we can retrieve our items. Where we can put some item and we can read some items. So we have like DynamoDB, for instance. We have another database like BigQuery for doing one set of analytical requests. Another one like Druid to do another analytical request, and we can have Elasticsearch to do some searches in our data. And by metrics, with having this metrics and alerts, we can check that we have added a specific number of records to each Kafka topic or database, and we can have alerts of them. So if we started receiving less data than we expecting, we can raise an alert, and then we can try to figure out what went wrong. But if we deployed something to a QA environment and everything works as before, I mean, without any problems, so yeah, this increases chances that everything will work in production, because also you'll just hear some configuration that you can spin up locally, like load balancers or networks or firewalls or something. Of course, networks in QA in production can be different, load balancers can be different, but the more infrastructure as a code you do, the more chances that you'll have similar infra in QA in production. Okay, so conclusion. Docker Compose infrastructure can help you to organize your development and test process. It's pretty the same way how you can set up tests everywhere, locally and in CI/CD. But also recommend to test everything heavily in QA environment by making automated requests to infrastructure, with special service, and verify that you have a specific amount of data in all your end databases. Okay, that's it from me, guys. So remember to support Ukraine. We still have a war in our country, so this is a government website that you can trust your donations. If you have any questions, we can talk about them in voice chat. You can ask questions in Discord. Here's my email, my website, where this presentation will appear soon, and basically Git repos with CI/CD, where you can which you can clone and play by yourself or extend to your needs. Yeah, thanks.
Thank you, Andrii, for the deep tech talk. I think while people are writing their questions to Discord, first question from me is, who is responsible for this QA infrastructure in your company? You have a separate team, or it's developers?
No, it's developers. So we are developing everything. So we are responsible for everything from writing the code to making sure that it works in production. So we write code, we write tests for it. We are lazy to do it manually, so we automate everything, obviously. And yeah, we have some responsibility to deploy it to production. So we do everything from the idea to something that works.
Cool, but you are not lazy enough to write all this infrastructure. Yes, I have seen you're using Mocha. I'm not sure why do not you using Jest?
That's a good Holy question. So as for me, Jest is more. Jest is better for front-end tests. So by default, it runs everything in parallel. Actually, it has a lot of built-in subsystems like test coverage, maybe some how it's called, assertion libraries. But personally, I love it to be separated. So I can use, for instance, Chai in my production code. So instead of using TypeScript, for instance, I can use Chai assertions to check some values in my code only where it's needed. So for me, it's more convenient. Yeah, I've tried to use Jest, but by default, Mocha is simpler for that. So by default, Mocha runs everything in a sequence, and it's pretty useful when you have a lot of tests that's connected to some third parties. So if you run this set of tests in Jest by default, it will you'll have more unpredictable states, just because it's pretty hard to separate infrastructure for every file.
Makes sense. Makes sense. So you're not writing front-end tests in your team. You're responsible for the backend. Yes.
Yeah, personally, I'm writing on the backend right now without frontend.
We have a comment in the Discord that Kafka starting from v3 doesn't require Zookeeper, so setup could be simplified. Just for information.
Yeah, I know. We're all waiting for that, but for now, I've checked Kafka infrastructure recently, and as far as I understand, it's not production ready, right? And we're using in production we're using Confluent, and I'm not sure if Confluent already switched to this new version. As far as I understand, as far as I remember, it's still in progress.
Thank you, Andrii. Also, have you succeeded at building continuous deployment process when each commit that goes in master is deployed without manual work?
Yeah, we can do that. So I did it in my previous project. For this one, we have multiple production systems, and we're using different environments as a blue-green deployment. So for instance, we have So as I said, we are doing deploy to production. After some time, is deployed to QA. So the process is next. So we deploy to QA first. We're trying to deploy everything from master. Then wait some time. If it's all good, then we deploy into our smaller cluster in Europe. We also have desired time span when to deploy, when it has less load, right? And then we deploy to US. It has a different time zone. We want to have different deployment time for that. Yeah, in general, we trust our tests a lot, so we can deploy it from master right away. The question is about infrastructure and rolling update in our real infrastructure. So imagine we have 400 containers in our application, and we need to do rollout update for all of them. So we need to add some, let's say, plus 30% of that containers. And so if you're doing the deployment during high peak time, you'll need to add more containers. It's more stressful for infra than to do it for smaller number of containers. Also, it's a matter of safety. If we deploy it like in the morning Ukrainian time, it's gonna be night in US. So in case of problems with infra or deployment, it will have less consequences, and because less users will see the problem.
Thank you, Andrii.